Hello, I am Sambhaji Patil. I welcome to all of you for this session. So in this session, we are going to see how to use Proteus software. Okay, so Proteus, it is the software which are using for circuit simulation and also for PCB designing. Okay, so we can see in this figure, we can see here is a transformer. Okay, here is a transformer. Then there is a sinusoidal signal generator, that is the main AC supply, 230 volt 50 Hz frequency we can apply here. Then we know that this is a step down transformer. So in the case of step down transformer, a transformer is working on working principle of mutual induction. It means that when current is flowing through the primary winding of transformer, it is producing the flux, and that flux is linking with secondary winding of transformer, and due to the flux linking there is a mutual induction and EMF induced in the secondary winding of transformer, and then current will be flow through the secondary winding of transformer. Okay, so transformer is working on working principle of mutual induction. Okay, then here we are using bridge wave rectifier. 4 diodes are connected. There is no any center type connection in the transformer. So PIV rating, that is a peak inverse voltage rating, it is a VM. So this diode is operating at maximum reverse voltage VM. In case of center type transformer, there is a 2 VM. Okay, so there is no any center type connection. So this is the full wave rectifier, bridge rectifier. So what is happening? The positive half cycle of input signal, diode D1 is conducting and D2 is conducting. During negative half cycle of input signal, diode D4 is conducting and D3 is conducting, and remaining diodes will be in off state. So here we need, this is the capacitor C1 470 microfarad. So this is the, we can say this is the polarity capacitor. This capacitor is having polarity, so that is the non-electrolytic capacitor. In case of non-electrolytic, which is operating at working on DC, which is having polarity, and it is a polarized capacitor. Polarized means this capacitor is having positive terminal and negative terminal. So in case of positive terminal and negative terminal, that is a polarized capacitor, we need to connect capacitor in proper polarity. If we are not connecting in proper polarity this capacitor, then it can damage or it can be burned. Okay, so this is capacitor C2 and capacitor C3. We can see here, this is the non-polarized capacitor, okay, which is not having any polarity. Okay, so this is the 0.015 microfarad capacitor, and here we need 7805, that is a positive voltage regulator. So we know that there is a 7805, it is a positive voltage regulator plus 5, and 7905, it is the negative voltage regulator. So in case of 7805, it is a positive voltage regulator. This voltage regulator is producing plus 5 volt DC output voltage, because what is happening, as we know that is the supplier side, there is a 230 volt AC input. Okay, and the signal is having the frequency 50 Hz. So frequency is nothing but the, we know that number of cycles in 1 second. Okay, that is a frequency, and here is frequency of the signal is 50 Hz. Then it is given to the, here is transformer, which is the 909, which is converting the high voltage to low voltage 909, and during positive half cycle D1 D2 will conduct, during negative half cycle D4 D3 will conduct, and we're getting the output voltage. Then okay, we're getting pulsating output voltage. So that pulsating, where we have to convert the constant DC output voltage. So that can be get with the help of this capacitor, because capacitor is passing AC component and it will be block the DC component, and we're getting output voltage should be regulated DC output voltage, where we want to get at the output side. Here is DC voltmeter is connected, okay, to measure the output voltage, and here is CRO has been connected, and we can check the output on oscilloscope. So now we can do this practically in the Proteus. We can see on the screen. We're going to go to the Proteus software, Proteus 8 Professional, and after going to Proteus, we can see here is software is loading. Wait for few seconds. Then here you have to click on for this software. We can see here, okay, this is the software. We can see you have to click on the new project. Click on the new project. Okay, after clicking on new project, initializing the project wizard, you have to wait for a few seconds. Here is you have to give title of this, what is the project you are going to design. Okay, suppose I am designing a rectifier. Okay, give name rectifier, and we can select the browser file where you want to store the data. So suppose it is by default it is selected a C column user search. Okay, documents is okay. Go to the next. Do not create schematic. Okay, next. Okay, next. Okay, then here you are getting on the screen, there is a new projector. Here is a save projector. Here is close project. This is home page. Then this is a schematic capture is available here. Okay, IS Proteus, and here is written ARES. This is a PCB layout. Here we can do. Here is a 3D visualizer. Here is a guide view. We can see the design explorer. This we can make it a bill of material and a source code. Okay, here is overview. We can see here. So you have to click on here IS, that is schematic capture, and after this you have to see this window. So in this window there is a component selection is possible, component mode, junction dot. Okay, click on P and you have to select the component. Suppose I want a AC source, so right here AC source, and you see that component which you are getting. Okay, voltage source, AC voltage source. Okay, that is a sign. AC voltage source is available here, that we can see. You have to click on OK and you have to put it here. Okay, then you have to click here and you have to also go to the transformer. Okay, we can select the transformer. Simple transformer is available. So this we can select. Wait for 1 minute. Okay. Simple transformer is available here, that we have to drag and drop here. Okay, you have to connect this component like this, and you have to select the diodes. Okay, what are the diodes are required? PN junction diode, generic diode is here, and analog devices. This diode you have to select here, click here, and you have to put this diode here. So how many diodes are required? 4 diodes. So we have to make a connection in that such way that. So already I have designed. I will open this project, okay, which is available here. You have to go to the project and open that project which is already saved. Okay, so there is sample is available. I think I will show here. Power pin diagram. Okay, we can see here project. Okay, open project. You have to go to the here. You have to go to here academic and PCB designing with pins and pin diagram we can select. Okay, so that we can open here and we can see. So such kind of diagram we can design. Here is a J1 J2 given. This is the diode is here, then here is a regulator, capacitor C1 C2 C3. Okay, and in the PCB layout we are getting such kind of PCB layout here. Okay, and this is the 3D visualizer we are getting. So this is possible with the help of Proteus software. Okay, so we can design with the help of the Proteus software this. So basically you have to know that once you go to here, you have to click on here PCB layout. After clicking on PCB layout, we are getting such kind of diagram, and here is you have to go to the tools, and after going to the tools you have to click on here auto placer. Okay, auto placer, and click on auto router. Okay, router. Before that you have to click here and you have to select the board edge, and you have to draw here board edge. Then you have to go to the tools, auto placer, auto router. This will be create. This is and we can arrange the component as per requirement, and we can see 3D visualizer. After this you have to go to here output, print setup, print layout. We can print layout as per needed. Okay, or we can export graphics, export as Adobe PDF. After clicking on here, it will be export as PDF. If you want mirror image, click on here, and after this we are getting mirror image. Okay, here we are getting mirror image. So where is that image? We are getting mirror image at the particular folder. Okay, which is we have saved. Okay, so important is the schematic capture. Here we can design schematic. This is the PCB layout. Here we can do simulation also. In the schematic capture, it is possible to do simulation. PCB layout, there is we are getting PCB. Okay, the component which are placed and we can arrange the component and we can trace the component, and you can see in the 3D visualizer like this. So here is you can see this is the bottom side. Okay, this is the front bottom front. This is the angle. Okay, this way, or we can do like this. This is a different way. We can see the components. It is a J1, 4 diodes. Before J1 there will be a transformer output. Okay, capacitor C1 C2 is here. Okay, then here is a 7805 regulator, and J2 is we are getting output. So in this way we can get a output in this. Okay, and we can with component and this without component. Okay, so I am very thankful to all of you for watching. So in today's lecture we have seen the PCB, okay, how to design, and we have seen that how to design PCB layout. Okay, so I am Sachin Sambhaji Patil. What we have seen in today's lecture, we have seen that how to use Proteus software. What is, we have seen schematic layout, how to components in schematic layout we can drag and drop and we can connect, and PCB layout we have seen, and 3D visualizer, and how to take print in the mirror image. Okay, So thank you all of you for watching this video.